Tasos, and I'm very excited to be here with you today to discuss an issue of energy conservation, which is a prevalent issue, and according to a recent report by McKinsey and Company, it is a 23% of our electrical energy is wasted. It's lost in the wire, inside your building, inside your facility. And that amounts to about $1.4 trillion a year of lost energy. This is money that you pay to the utility company, but this is energy that you never use. So I have a demonstration here today that will show you how this energy is lost. It will demonstrate, it will show you the actual energy that is lost inside your facility. And I will also demonstrate for you a way that we have of treating that lost energy and recapturing it for you. And by doing so, we're able to lower your electrical bill, and we're able to give you a very good savings, which could amount to 15, 20, sometimes 30%. So to start the demonstration, what I have here, I have a wire that basically simulates your most favorable charity, the utility company. I have a meter which basically is similar to the meter that you have at the outside of your place of business, which measures the amount of watts being used. I have a motor that is a simulation of any type of load, whether it be an air conditioner, a refrigeration unit, a conveyor belt, some sort of a machinery that's being used. On the motor I have a meter that basically reads the amount of energy being used by the motor at different periods of time, and I will measure that in amps. And I have a wire that basically will bring energy to my motor, and I also have a plug that will allow me access to the motor by my conditioning product. Notice that the motor will be running when I plug in my power conditioner, and what that means is it means that it will be basically connected to my motor on a parallel electrically on a parallel basis. This is not something that's of interest to you, but I'm just telling you in anyway. So what I'm doing is I am turning on my motor, and what I will see is that at the meter, if the motor is located very close to the meter, I am using about 142 watts of energy, and the amount of current being used is about 4.9, 4.8 amps. Okay, so that serves as the basis for what we're trying to measure here. So what I will do right now is add an additional, I will add 100 feet of wire, which is a simulation. Most of the time when you have a motor, when you have an air conditioner, it's not sitting right next to the meter. It's sitting far away from it, and you only know how far away it is. So by adding this 100 feet of wire, what we will see is that the wattage have gone up from 144 to 160 watts. My current remains at 4.8 amps. So nothing has changed with the operation of the motor, but because of this 100 feet of wire, I have added 15 watts of energy, which is about 10% more energy required. Now what I will do is I will add another 100 feet of wire. If I can get it. And this additional, so with 200 feet of wire, what I have is my energy use is going up to 174 watts. amps. So by adding 200 feet of wire, I added 20% to my overall energy usage. That right there illustrates that just by adding wire, I added more energy use into my system. Now what I will do is I will add the treatment product I was telling you about, and let's see what happens. My current is still 4.7 amps, so nothing has really changed to the motor. And as you noticed, I didn't turn off the motor, so the motor is still operating. This product was added while the motor was being in use. And my energy use is now 140 watts. Wow, you say. So by just adding this product very close to my load, I have been able to eliminate the loss that was due to the wiring inside the system, inside my facility, inside my building. Now, is this something new? Is this something that the utility companies don't know about? No. It's actually a very well-known fact. And if you notice, when you're driving outside, anytime there's a home, business, you will find that utility companies have actually installed these treatment units on the poles. And what they have done is they have been able to eliminate some of the losses inside their system. And you could ask the question, well, why don't they fix your system? And the reason is very simple. Utility companies are not in the business of saving you money. They're in the business of selling you as much energy as possible. That's how they make their money. So there's really no interest of theirs to help you save this lost energy. And that's the answer to that. Now, one other thing is, a lot of people ask me, is this power factor correction? And I will say, no, it isn't. What we do has nothing to do with power factor correction, although what we do does, in many ways, help with your power factor. But just to illustrate again that what we do is not power factor correction, I will do one more thing to demonstrate what I just said. As you will notice, I have the 200 feet of wire, have my motor running, and you will see that the amount of power being used is 179 watts, which it was prior to me adding this conditioning product. So usually in power factor correction, what they do is they take a product similar to what we have here, and what they do is they basically connect it right next to your junction box or your fuse box. Okay, so if I did that right here, you will see that the amount of energy remains to be 177 watts. What does that mean? That means I have not eliminated the energy being lost inside my wire. Now, have I improved my power factor? Well, we can see that. The nice meter I have here actually measures power factor. So with the conditioning unit, my power factor is 0.71. When I remove it, my power factor is 0.31. So, can a product like this correct the power factor at the box? It can. It can correct it. But placing the product like this right next to the box is not going to save me any energy whatsoever.